Hello everyone, I am Azrina. I'm representative from Group 2 for Theory of Structure case study. Our group member, we have five, me, myself, and next we have Nurul Atika, next Chong. The fourth one is Hairul Ikwan, and the last one is Ahmed Al-Sadiq. For our case study, the title is Pellet Rack Collapse. For our introduction, this case study is investigate the sudden collapse of modular steel pellet rack system during the routine loading. And the failure is occur at the moment frame and causing a major material losses. For our objective, we will determine or identify the root causes through analysis of load transfer, and we will design and using a checking. And next, we have the system description, which is a number of columns. We have four parallel columns. For the pellet load, it carry 10,000 Newton. And then the spacing, we have 1.4 meter. And the height of the modular rack is 9.8 meter. And then for the cross section, it is 120 multiplied by 120 millimeter. For the thickness is 2.5 millimeter. Next, the load transfer mechanism, which is I have include the direction of the load transfer at the right side. So for each pellet, it's carry 10,000 load transfer through the bracket to the column, to the base plate, and to the anchor bolt. And the last one is to the concrete slab. For the bracket support, the load is in axial compression, while the base plate is anchored to a 200 millimeter slab to ensure the foundation is stable. And the lateral force are resisted by the moment frame, tie beams, and bracing, especially along the A and B axis.
Okay, my name is Nurul Atika binti Arba'in and I will present about moment frame analysis. So this frame is classified as a non-sway frame based on the three key consideration, which is the first one is the presence of bracing. Diagonal braces are installed along the A and B direction, which it forming a strong triangular system, and this setup increases the lateral stiffness and helps prevent sideways movement. And then the second one is load path and direction. Loads are transferred through both column and braces, meaning the brace help resist lateral force, which keep the frame stable during the loading. And then the third one is structural behavior, which is the brace frame like this are considered as non-sway system. And then we go for the second one, which is the distribution factor and fixed end moment. So before applying the moment distribution method, we need to calculate two things, which is the first one is distribution factor and then the second one is fixed end moment. And then for the third one, we move to the moment distribution method, which allow us to calculate the final bending moment at the joints. And then after that, we find the bending moments. We calculate the shear force using static equation, which is we use the summation of Fy and summation of Fx. And then the last one is the shear force and bending moment diagram. So using the moment and shear values, we can now draw the shear force diagram SFD and the bending moment diagram BMD.
Good morning, Dr. Reza. I'm Chong Yok Wei, and I'm going to present about the hypothesis of failure. So our group have made three hypotheses for this moment frame failure. So the first hypothesis is inadequate lateral stability on the moment frame. So as we know that the 9.8 meter tall columns is only supported by a single tie beam at the roof level. So this single tie beam might not provide an adequate lateral restraint for the columns. So this will lead to the instability of the moment frame, especially during the asymmetric loading. So this asymmetric loading during the partial pellet placement will cause sway, and in the end this will lead to the columns to be buckled near the base plate where the bending moment is peak. So for the second hypothesis is the failure at the base plate anchorage. There is only four 16 mm bolts used to anchor a base plate to a concrete slab. So during the asymmetric loading, the uplift force on one side of the concrete slab may exceed the tensile capacity of the bolts. So this will lead to the column to be rotated and the frame to be collapsed. The third hypothesis is the resonance in the frame. As we all know that the moment frame has a natural low frequency, and during the daily operations, the moment frame natural frequency might resonate with the forklift displacement vibrations or any other vibrations that made by the workers. So this resonance will increase the lateral displacement, causing the tie beam to be overstressed. And in the end, this will lead to the beam buckling and connection failure. So that's all from me. Thank you.
Hey everyone, my name is Hari Ikhwan Bihim Zaifullah. I'm from the group 2 of the TOS project, and I will explain the plastic analysis to estimate the minimum force from a forklift that can cause the collapse of the pallet rack system. So, first and foremost, we assume that the rack system is completely empty, and the forklift accidentally strike the column at the height of 1.4 meter from the base. This creates a plastic hinge mechanism, which we will analyze using the plastic analysis. There are three possible collapses. The first of all is at the base of the rack system, at the impact point of the 1.4 meter from the base over here, which is the forklift, and at the top of the column. First of all, we calculate that the delta is equal to 1.4 times theta. Delta over here is 1.4 times theta. The same is with the beta. Delta is 8.4 beta. 8.4 beta. So we know that the external work is equal to internal work. So we use this value from earlier and we put it here, and we will get the 8.4 beta P is equal to 14 MP beta. So from this equation, we will get that the P is equal to 1.67 MP. So the next step, we need to find the MP. MP is equal to the ZP plus sigma Y. So from this formula earlier, MP ZP times sigma Y, we will get that the MP is equal to 14.5 kilonewton meter. We will get that the P is equal to 1.67 times 14.5, which will equal to 24.215 kilonewton.
Hello, this is Ahmed, and I will continue on recommendations and conclusion. For our recommendations, we focused on key three areas: design, operation, and maintenance. First, for design, we suggest intermediate bracing along moment frame to prevent sway and second-order effects. Because the current system only has one single tie beam at the top, which is not enough. Second, we recommend adding more force on the brackets, tie beams, and base connections to handle bending and lateral forces more safely. And third, to improve real-world safety by installing guardrails to protect against forklift collisions and make sure pallet loading is even and balanced. Inspections and monitoring should be done. These techniques combined will significantly reduce the risk of future collapse. In conclusion, our investigation shows that the collapse was likely due to a combination of lateral instability and under-design connections, especially in the moment frame direction. The brackets and anchor bolts were near to their limits, and the lack of bracing made the frame vulnerable to sway. Plastic analysis found that a forklift impact of 24.2 kilonewtons could collapse the empty frame. This case shows that design must consider both static and real-world dynamic loads. By implementing better bracing beta connections, and proper inspection routines, similar failures can be avoided in the future. That was Group 2 on Theory Project, and thanks for listening.